and we are then going to be writing our note. Okay, so today we are going to still do ionic compounds. Remember, an ionic compound is a compound that contains a metal atom, ion, at the front with non-metal ions at the back, and they stick together like magnets do because of their opposite charge. Yesterday we learned how to determine the formula by taking those charges and crossing them over and then canceling out any common factor, right? Now what we want to deal with today is ionic compounds that contain what are called polyatomic ions. And I'm going to first explain what a polyatomic ion is, and then I'm going to show you how to get the names and the formulas. The process is the same. It's just we've got to deal with a slightly different looking ion in this particular type of problem. So first, what is a polyatomic ion? You can write down the definition of that. It is a group of atoms that has a charge. They are bonded together, so they are bonded together to other ions by an ionic bond. So it turns out, and this is fairly complex stuff. This is what the explanation that I'm going to give you right now is more complex than you need to know for this course. But I feel I want to show you and tell you in a little more detail what a polyatomic ion is. So I'm going to draw something here on the slide. You can draw it, but you don't need this information in this class, okay? But again, I like to just kind of make sure that you've got the information. I want to see what my next slide is. That's okay. I'm going to go back. That's okay. I'm going to go back. So let me explain to you in a little more detail what a polyatomic ion is. So there are a group of atoms that have a charge, and let me explain what the group of atoms looks like. So I'm going to put a couple of examples down here underneath, and you can write this down. Just come around this way so we don't bump our cart, all right? And you can leave the periodic table on the desk. I'll get it. So let's first start with something that we know. Something that we know is Cl-, chlorine with a -1 charge. I'll put -1 because that's what we see on our periodic table, right? You know, if we're dealing with chloride, I go to the table, I look at the chart, I see -1. Now, we've seen what the diagram of that chloride looks like. It's a Cl that has 8 electrons around it, and then we put a square bracket around it and put -1. So that's what that thing actually looks like. It's got a chlorine with 8 electrons. It gained an extra 1. That's why it's -1. That's not a polyatomic ion. That's just a regular ion chloride. One of the polyatomic ions that we're going to learn about, and I'll just write down here what it's called. It's called, oops, got it backwards. Can you scribble that out completely? Chloride. Okay? One of the polyatomic ions that we're going to learn about is ClO3, and it also has a charge of -1. All right? So it's some oxygens stuck to that Cl. It looks like this. Now, this is the thing that you don't have to worry about in this course, but I'm going to draw it. It looks like this. It's a Cl that has 2 electrons, and then it has these bonds that are stuck to these oxygens. The oxygens have some electrons, all right? And it turns out that this entire thing has a -1 charge. So it's an ion like chloride that has other atoms stuck to it. But when we do chemistry, that thing behaves just like a chloride. When it reacts with something, we will cross over the charge, that -1 charge, just like we do for the chloride ion. This particular ion is called chlorate. It turns out that chemists years ago, when they found these ions, when they were bonded with oxygen, they gave it an ate ending instead of an ide ending. So it's chlorate. Now, that's what a polyatomic ion is. It's an ion that behaves just like a regular ion, except it's got some extra atoms stuck to it. That's all you need to know. When we do the formulas, we're going to cross it over just like regular. And when we do the names, instead of calling it an ide, we'll call it chlorate. Now, how are you going to know how to name all these things? Well, I don't expect you to know how to name all these things. And you don't have to write this down. This information is on the periodic table. Now, when I made the periodic tables yesterday, I had hoped that that little chart that is at the top of the table would be dark enough that we could see all those charges. Let's take a look at that chart right now, and I'm hoping your eyes are good, unlike my eyes. And I'm hoping that we can see there, just like this chart, it says nitrate, hydroxide, bicarbonate, chlorate, carbonate, sulfate, and phosphate. And I'm hoping, and the big thing that we need to see is the number of O's and the charge. Can we see that on our chart? Because if we can't, I'm going to have to create a new chart for you when we do these problems. But I'm hoping that we can see there that it's ClO3, CO3, SO4, PO4. Can we see those numbers? If we get to a test or something and you can't discern what that is, you can just ask me and I can tell you what that number is, okay? So I'm hoping we can also see the charge. -1, -1, -1, -1, -2 for the carbonate, -2 for the sulfate, and -3 for the phosphate. Can we see those numbers? Are we okay for seeing them? If not, again, I might have to do a reprinting, but for now, I'm hoping we can get away with using this. Okay, so let's practice doing some naming with this stuff. So just put names to formula, all right? Just put names to formula. And I don't like the way we've got all these boxes. Just write down aluminum chlorate. Just write that down. So names to formula and write down aluminum chlorate. And then we're just going to do these examples. So I'm going to, in the middle, put the charges like we did when we started yesterday. Then we'll cross them over like we did yesterday. And then we'll write the final formula over here on the side. So aluminum, we're going to write down aluminum. And we know already that we're going to need the charge for that. So what is the charge on an aluminum ion? Using our periodic table, what's the charge on an aluminum ion? Yep, Zach, it's a +3. So we write it down. Or we have it in our mind. But some of us were getting really good at it, and we can do that again when we get good at this. Now we need chlorate. So here's what you have to do, especially later on my assignment, because my assignment's going to have some chlorides, and it's also going to have some chlorates. So you've got to remember that if it ends in ide, you're just using the atom. And if it ends in ate, you've got to go to the chart to find it. So what's the formula for a chlorate? All I'm doing here is making you find it on the chart. Tyson, what is it? Chlorate. Track it down. That's an L, but that's okay. ClO3. ClO3. We put it in brackets. What's the charge on that chlorate? Tyson? -1, but we're going to get rid of it when we cross it over. You're right, it's 1, -1. So what we do now is, again, we cross our charges over, and we get rid of the sign. And if there's any common factor, we divide it away, just like we did before. So our 1 is going over there. We don't write in the 1s. Our 3 is going over there. Now notice that there's brackets there. Let me rewrite the final equation. Al brackets ClO3 brackets 3. So what does that mean? That means that there's one aluminum atom, and there are 3 of those big chlorate things stuck to that aluminum atom. The formula, if you'll notice, looks just like aluminum chloride. If we did aluminum chloride, it would be AlCl, the 3 would go over there, but simply instead of the chloride, we've got the chlorate in its place. So you've got to have the brackets, because that tells us how many of those chlorates there are. Okay? So all we're doing differently now is it's almost like we've extended our periodic table. Don't write down names to formula again. Just put example 2, put silver sulfate. Track down the silver, find the charge, track down sulfate, put it in brackets, track down its charge, cross it over. Silver is one of those that I forgot to talk about. It's not in this main group, it's right there, but we use it quite a bit, and you can find the charge right on the table. What is the charge on a silver? What is the charge on a silver? Yep, positive 1, plus 1. You can just put a 1. Some people were just putting 1 when they were doing the practice and crossing it over. That's fine. Now I need the formula for a sulfate. Formula for a sulfate. Nolan, what do you got? That's enough hands up for me. That's good enough. That arm coming up was good. You can find it here on the front, or take a look at your periodic table. Find that sulfate in that little box there. This might be a test that you can read the numbers. SO4, excellent, that's correct. And what's the charge? Yeah, -2, it's correct. Cross them over and rewrite. Notice the 1 is going to come out here, outside of the brackets. Remember, we don't need to write a 1. The 2 is going to go over there with the silver. This is going to be AgSO4, and then just a 1. Oops, I forgot to write the 2. You know, I forgot to write the 2. I was going to say something to you. Okay, I got the 2. I've got it fixed. Everybody's okay? In most textbooks, they would now take the brackets away because there's a 1 out here. When there's a 1, the brackets aren't needed because there's only 1 of them. If you leave the brackets in when you do your worksheet or an assignment or a test, that's okay. I'm not going to take marks away. But in a proper textbook or a proper thing, it would be written as Ag2SO4, and because there's a 1, the brackets are not required. But you can leave them in if you want. I don't care. Zinc bicarbonate. Zinc is one we haven't used, but again, you can find it on the table. It is a metal, and it's very close to silver. It's right in that position, so you should be able to find its charge on your periodic table. Again, bicarbonate will be on that chart. Put it in brackets, find its charge, cross it over. Some of us might be getting good enough at just doing the crossover and not worrying about the middle step. If that's you, that's great. If that's not you, it's not a big deal. You can show me the middle step on a test or on an assignment or on a quiz. I'm going to jump right to the end on this one. I'm going to see if someone has done the whole process, whether you wrote the middle down or not. Zinc, Zn. Formula for bicarbonate. What am I putting in the brackets in this one? Let's get somebody else. Yep, Eric. CO3. Tell me what numbers I need on the bottom here in order to finish this. I'm going to finish the crossover now. What's going to go down here? How do I finish that? Do you have it? Jacqueline, what do you got? 2 after the bracket. Correct. Zinc's 2 came over here. The 1 went over there. That's done. That's zinc bicarbonate. Nice job. Let's do one more, and then we'll go to the naming. Sorry, calcium hydroxide. Again, I'm just going to write the answer down when you guys have it. And now I'm going to get you guys to just tell me what to write. And if you want me to write a bracket, just say brackets. And I'll know to write the left one. And at the end, just say brackets again. And I'll know to write the right one. And then just tell me what numbers I need to write when we get to it in the formula, because I know they've got to be small. So if someone could tell me what their formula reads like when they read it across. What does the formula read like? Lucas thinks he's got it, I think. He's giving me an approving look with his eyes when he was done that. So just read me the elements, just the symbols. You don't even have to say capitals because I know what to do. Just say brackets when I need to put a bracket. Go ahead. CA, bracket. OH, bracket. 2. Correct. That is calcium hydroxide. The 2 from the calcium went across to the hydroxide. The charge on the hydroxide is 1. Goes with the calcium, we don't write it in. Excellent job. So that's how we deal with polyatomic ions. We don't deal with them any differently than we did with yesterday. We just put brackets around it. That's it. Okay? Again, in our summary assignment that I'm gonna give at the end of class, well, hopefully before the end, I want you to be able to have time to finish it. There's gonna be a mix. If it ends in "ide," you're just putting the element. Except for one. This is an exception. Notice it ends in "ide." Hydroxide is a mixture of hydrogen and oxygen together in one. That's the only one that ends in "ide that isn't just an element on its own. So if it ends in "ide," except for hydroxide, you're just looking at these guys. If it ends in "ate," it's a polyatomic ion. Let's go the other way. Formulas to names. You can write down formulas to names. Just put example. You don't need to have it in a box. Formulas to names, examples. Now remember, yesterday we stopped and we worked a little bit on them, and then we went back and did the formulas to names. Now we're going to do it all in one shot, and then we're going to, I'm going to let you work on a practice sheet, and then I'll assign the assignment, and then you can work on the assignment. Okay? Yep. Goodness gracious, he's given me the answer right off the hop there. That is correct. I didn't want that answer yet. But he obviously likes the Toronto Maple Leafs, and so he's eager like all true good Toronto Maple Leafs fans. So that's an acceptable thing to do just for Toronto Maple Leafs fans. Jays fans, I don't know. Are we concerned about the Jays? We're concerned, aren't we? Are you going to tell me what fan you are? Is that what you're going to tell me? No. Okay. Yep. No, the numbers don't come into play. You just name the front ion and the back ion. And that's a good question. I'm gonna put this answer down here. What are we saying? Lithium, and then you'll notice there's a carbonate. Carbonate. The question was, do we have to put the numbers down in some way when we're talking about the names? And we don't. And here's why. Because as chemists, and I'm including you as chemists, congratulations, you're chemists. Because as chemists, we know how to cross over the numbers to get the formula. All you need to say to me is lithium carbonate. And you could then go to a periodic table, cross the charges over, and get the right formula. So because we know how to determine the formula from that name, there's no need to put numbers in it, because we know how to use our periodic table to get the correct numbers. You see what I mean? We have the knowledge to get the right formula based on that name. We don't need any extra information. Okay? That's why we don't put the numbers in. Let's do another one here. So again, we're not worried about the numbers. We're just worried about naming the ions. Again, you'll notice this group of atoms. That's going to indicate to you that you got to go to the chart. By the way, let's say you're doing a test and you're panicking. There will never, ever be an answer like aluminum nitrogen 3-oxygen or something. You see what I mean? There's no name of just throwing names of elements out there. You always have two parts to the name. You name the positive chunk, the positive ion, and then you name the negative chunk, the negative ion. So it's always two pieces to the name. What is the name of this stuff? Yep. Aluminum nitrate. Aluminum nitrate. The front part of the name, the positive ion, the back part of the name, the negative ion. Excellent. Always two pieces to that name. This will be our last one. Then we'll do a couple of practice ones on the whiteboards, and then I will let you work on the practice sheet. And then once we've got that mostly done, I will then release the assignment. If I release the assignment now, you'll all go straight to the assignment. I want you to do a few practice ones. Yeah, see how that goes? That's good. What's the name of this thing? Yep. Gallium phosphate. Yep, gallium phosphate. Two L's in gallium? Hold, I think did I screw that up earlier on? I did, look at there, just one. Gallium phosphate. Excellent. I'm going to stop my recording because I don't need to be recording as we do a few little practice runs here. So I'm going to stop that. And you guys know the way on.